What technique was it? So this is 32, right? Anybody remember? We looked at only one technique in section 3.2. It's the simplest of them all. Morgan. Exactly, the x and y intercepts. So in 3.2 we did an example of graphing by intercepts. You also had a quiz, and on the quiz I asked you to graph an equation by using the x and y intercepts. It is the easiest way to graph a line. Obviously, if it's given in slope-intercept form, you could start at the y-intercept and go up and over, sure. But if you're ever given something in standard form specifically, this is when it's really useful. Okay, you don't have to actually figure out what the slope is by using negative a over b and that y-intercept or another point. Just find the two intercepts and connect the two dots. All you need are 2 points to make any line, remember that. So if you have two intercepts, you have the line itself. So for example, if I were to graph this, oh, it's going to appear in a second. It's a little delayed. Come on, AirPlay. Make it over. Tell me the Wi-Fi went out. If you're going to graph, I'll read it to you, okay? Negative 3x plus 5y equals 30. Negative 3x plus 5y equals 30. I'm going to try and reconnect. Find out what the intercepts are, please. Tell me AirPlay went out altogether. Really? What do you get for the x-intercept? What's the x-intercept in this problem? How do you figure it out and what do you get? Those two things? Chandler?
You set y to 0. So
yeah.
X would be negative 10.
Do that and then divide. X is going to be negative 10. Very good. So the x-intercept, its coordinate is negative 10 comma 0. Right, its actual coordinate. What about the y-intercept? Christian, the y-intercept, what do you do?
The y-intercept? I don't have...
It's not up on the board, that's why. Remember, the board's not showing, it's not AirPlane. So if you want to get the y, to get the x-intercept, we set x equal to 0, set y equal to 0, we got x equals negative 10 for the x-intercept.
So then you plug negative 10 in for x?
Well, that'll just give you 0, right? That's the coordinate right there. If you plug, are you listening to what we're saying?
Yeah.
If you plug negative 10 in for x, you're going to get 0 for y. That's the x-intercept. I'm saying, how do you find the y-intercept? How do you find the y-intercept? What's the opposite of doing what we just did? Somebody help me out, please. Come on, you got to stay with us because this is like the easiest part of this chapter. M. Yeah, just set x to 0. If you want the y-intercept, set x to 0. If you want the x-intercept, set y to 0. Come on, people, let's go. Let's get through this a little bit quicker. So set x to 0, we're going to end up with 5y equals 30. And therefore, y equals 6. So the y-intercept, its coordinate is 0, comma 6. Let's see if this... All right, so I'm gonna have to write on the board. I'm gonna still record. It's just gonna record sound because I can't write on here and you guys can't see it. So I'm gonna have to just write on the board now. All right. So after that, in that section, about the idea of horizontal and vertical lines. Horizontal and vertical lines. What do you know about them? Tell me what you understand about horizontal and vertical. Go.
Horizontal line has a 0 slope and a vertical line has an undefined slope.
All right, good. So horizontal, let's first, for this one right there, the slope equals 0. Good. And for vertical, the slope is undefined. Very good. What about the equations of those lines? The equation of a horizontal line as opposed to the equation of a vertical line. What do we know? Give me an example of the equation of a horizontal line. What would the equation be, for example?
Y equals -7.
Yeah. So a horizontal line, its equation is given by y equals some number. I did not push a button. That's a weird one. It's y equals some number. How about the vertical line? Instead of y equals some number, what's the vertical one going to be? I know. What's the vertical one going to be? Yeah, x equals some number. And if you got confused about how this is true, simply look at a vertical line. A vertical line consists of an infinite amount of vertical points stacked on top of each other. If I connect all those dots, that's a vertical line, isn't it? The x-coordinate for every single one of those is the same. Let's say this is 4, 5, 4, 3, 4, 2, 4, 1, 4, -1. I don't have to keep doing this, we get the idea. The x-coordinate is always 4. So the equation of the vertical line is x equals 4. Okay, that's the line x equals 4. Simply because the x is always 4. So if you forget which is y equals, which is x equals, literally draw a vertical or horizontal line, list all the points on it, or list several of them, and you'll notice that when you do it for vertical, the x values are always the same. So x has to be equal to some number always. That's the equation, because they're always the same. But if you did a horizontal line, it would be y equals, because a horizontal line down here maybe, let's call this y equals -7. Means that every point on this line has a height or a y value of -7. This could be like -5, -7, -2, -7. This over here might be 4, -7. But all the y values are -7, so this line is y equals -7. Okay, it's a constant function because y is always the same. The other one is constant, but we don't call it a function. We'll talk about that a little bit later in the chapter. Okay, but horizontal and vertical lines. Let me see if the AirPlay will connect now. Maybe we can go back to this so the recording it'll show on. I don't get this. Why is this not connecting? Okay, we have that. What else about slope?
y2 minus y1 over x2 minus
Yeah, that's another way to write it. y2 minus y1 over x2 minus x1. We've kind of exhausted all the ways to write it at this point. You could also just write vertical over horizontal. It's fine too. What about positive versus negative slope? Think back to your quarter 1 project you did. And some I know that weather did not turn out to be a great data set to use, I guess, due to the fluctuation of the weather so much this month. But the general idea, what was the idea behind positive and negative slope? What does that mean? Positive slope, what does that mean to you?
It's going up.
What's going up?
The slope of the data.
Not the slope of the data, no. The slope is positive, it's not going up. If the slope was going up, it would look like this. Right? It would curve up like a parabola. What about the point? It's what is going up. Its value, very good. Its value or its y coordinate. Either one is fine. The concept is that for an increasing function, so positive slope indicates, and I know you knew what it meant, like visually, but to describe it, okay, you would say the function's value or the y coordinate or the height of the function is increasing or going up. That's what positive slope looks like, and obviously negative slope is the opposite of that. Okay, zero slope means exactly that. It means that the y value is not changing. So zero slope means that the y is this, right? Here's the y value the whole time. It's constant. It's a horizontal line when there's no slope. Yeah?
If the slope is, if like the denominator for a slope is 0, does that mean it's undefined?
That's correct. Whenever the denominator for slope is 0, because you can't divide by 0, that's a vertical line. It's undefined.
And then when numerator is 0, it's horizontal.
Correct, because the slope is 0 then. 0 over any number is 0. Now, if you happen to get 0 over 0, that wouldn't make any sense, because then you wouldn't move. You'd only be at a point, right? If you had 0 over 0 as your slope, it doesn't make any sense. No vertical motion and no horizontal. It's nothing. It's one dimension. Point. All right, so we know what slope is in general. So let's give an example where I give you 2 coordinates. Start by finding the slope, and then we'll move into the equation of the line. So for these 2 coordinates, let's say we've got 2, 7, and -4, 5. Those are the 2 coordinates. Find the slope between them, please. Slope, Will, what do you got? 1/3. Others agree or disagree? Agree? Okay, I'll take you on your word. Good. So we have the slope is 1/3. I'm trying one more time for be an ongoing thing. If it doesn't work today, it's probably not going to work tomorrow. I got to let them know. No, not working again. All right. Slope, good. Now, if that's the slope, can somebody tell me what the equation of this line could look like, and how we go about doing that? And if I just say equation of this line, I'm not specifying. So what do you have as options? Tell me what your options are. Which ways could you approach this problem? How could you tackle it? There are 3 options.
Y equals mx plus b.
You can start with y equals mx plus b because you know m. You can plug in a point and get b. That's one option. Second option.
Just standard form. So plug in one of the coordinates and the slope.
Yeah, you know that ax plus by equals c. You know slope is negative a over b, so you can do that and use that. And the third option?
Point slope.
Point slope. You got a point, you got a slope. So let's go ahead and go through all 3 of those. Okay, let's do them over here. And we'll get the same answer all 3 ways. You kind of did this in class already. You should be able to do this easily. Okay, if I give you something, you should be able to come up with this equation in any of the 3 forms. So we have, I'll start with standard because it's over here on the top. So ax plus by equals c. Remembering in standard form that the slope is equal to negative a over b. That's one of our key facts there. Negative a over b is slope. So if our slope is negative 1/3, it means that we can make a negative 1 and b 3. Right? Because we'd have negative negative 1, making it positive, over 3. So in our case, we'll say a is going to be negative 1. B is going to be 3. We don't know what C is. Again, just literally look at this. If I tried to find the slope, wouldn't it be 1/3? It'd be negative negative 1 over 3. So I'm going to use negative 1x plus 3y equals c. And it looks like it's confusing, but all you need to do now is use one of these points. Either one. I would use the one that's both positive, just because it's easier with positive numbers. So plug in 2 and 7 for x and y and get c. Apply 2, 7 to this, giving us negative 1 times 2 plus 3 times 7 equals c. This is negative 2 plus 21 equals c. C is 19. If c is 19, my final answer is going to be negative x plus 3y equals 19. Okay, I take that form I had at the top, I solve for c, and rewrite my final answer. That's in standard form. Who could step me through point slope? Point slope. Yeah. Let's go to point slope.
Y minus y1 equals m times x minus x1.
Good. What do I do next?
You plug in 7 for y1.
Okay, so you're going to use the first coordinate. That works for me.
And then you plug in the slope for m.
Good. 1/3.
And then x x1 is 2.
Very good. Okay, so we only have to apply 1 point. 1 point here. Remember, we don't need both points. We use both points to come up with a slope. But once we have a point and a slope, all we need is that 1 point. Just like in the last problem, when we did it with standard form, we only have to use one of the points. You're never going to have to use both points unless you're calculating the slope. Once you have the slope, all you need is 1 point. So as a result, I can leave it this way if I wanted to, honestly. If I asked you and I didn't give you a specified form, or if I said use point slope, you could leave it like that. Or you could convert this to another form. Let's convert it to slope intercept. So that when we do the next example with slope intercept, I'll do that one also. Okay, we'll do that one next. When we do slope intercept in a moment, we'll prove that they're the same. So to make this into slope intercept, what would I have to do? Make this into slope intercept. I want to get y by itself, don't I?
Yeah.
So what would I have to do?
Bring 7 together.
Yeah, bring 7 over. Now remember that the plus 7 is going to be out here. So we have to distribute the 1/3 at the same time. So I'm going to get y equals, distributing the 1/3, it's 1/3 x minus 2/3. 2 times a third is 2/3 there. Plus 7 on the end. So y equals 1/3 x. Now 7 and a negative 2/3 is 6 1/3. Your y-intercept can most definitely be a fraction. Okay? 6 1/3. Now, what's 6 1/3 though? Isn't that 19 over 3? Do the math. 6 1/3. Isn't that 19 over 3? Not a coincidence. Look, I told you this little secret that the y-intercept in standard form is going to always be equal to c over b. 19 over 3. 6 1/3. 19 over 3. It's not a coincidence. These things happen for a reason. Okay, so that's the truth. This is always going to be that way, which gives us 6 1/3. Now, that's in standard form, and that's in slope-intercept form, and we got that from point slope. So we really don't have to do this again. But if I wanted to show how to do it, here's what I would do. For slope-intercept, you start with slope-intercept, plug in your slope, and then apply a point. Just like we plugged in the slope over here, and then we applied 2, 7, we applied 2, 7 over here, apply 2, 7 over here. And you're going to get 7 minus this 2/3, right? Think about it. We have 7 over here. This is 1/3 times 2 is 2/3. So you're going to have 7 equals 2/3 plus b. Subtract 2/3, giving you 6 1/3 for b. The same answer, which would yield this solution down here. Okay, no matter what way you do this problem, it's the same linear function, just written differently. Okay, just written differently. Nobody's missing today, right? Inigo's out. See, it's what sucks that it's not on airplane now. Sorry, Inigo, if you're listening tonight. It's the truth, you know? Alright, let's do one now that involves parallel and perpendicular, that notion. First of all, what do I know about parallel and perpendicular? What do I know about lines and parallel and perpendicular? How do they relate? I'll give you something, yeah.
Parallel has the same slope. Perpendicular has the negative reciprocal.
Yeah, parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. So, let's say I want to know the equation of a line. Okay, find the equation of a line. Parallel to 2x plus 4y equals 7. And that goes through 1, 3. Find the equation of a line parallel to 2x plus 4y equals 7, and that goes through the point 1, 3. It goes to the point 1, 3. So it's parallel to that first equation. So if it's parallel to that equation, what should I do?
Find the slope.
What's the slope of the first one?
Y equals, n equals negative 2, -2/4.
Good. Negative A over B, right? That's how you always do it. You don't have to resolve for y if you were doing that. Yeah, just use negative A over B. So it's -1/2. That's the slope of the line given. And we want it to be parallel to that, so we're going to use that slope, because they should have the same slope when they're parallel. I wanted to go through this point 1, 3. So I also have the point 1, 3. So use point slope, use slope intercept, whatever you want at this point. I'll use slope intercept. Y equals -1/2 x plus b. The -1/2 comes from the slope. I'll apply the point 1, 3. When you apply a point, it means you're putting that point in for x and y, because it satisfies the equation, because it's on the line. So 3 equals -1/2 times 1 plus b. Solving for b, we're going to add a half over, so b is 3.5. So the equation of the line in the end is going to be y equals -1/2 x plus 3.5. And that's going to be parallel to the line that's given at the top there. Okay? They're going to be next to each other. If I wanted to graph them together, this is what they would look like. Bless you. Here's 3.5. Here's a negative slope, -1/2. There's that line right there that we just solved for. Okay, -1/2 x plus 3.5. Now, if I wanted to graph the other one from the beginning, the slope was also -1/2, right? What's the y-intercept in this one? What's c over b? C over b turns out to be what? 7/4. 1.75. So I'm going to go to about here and draw the same sloped line. They are never going to intersect. They are parallel to one another. Okay, so this original line we had is the bottom one. The new line we got an answer to was the top one. And does it go through the point 1, 3? Sure it does. Here's over at 1, here's up at 3, goes right through that point 1, 3. Okay, 1, 3 is what we're going for, 1, 3. Now if a line is perpendicular instead of parallel, all I have to do is what again? Like literally change this word right here, please, to perpendicular. Change that to perpendicular. And what happens? What happens? What happens? Alex? Yeah, you not only switch it, but you also have to do what?
Reciprocal?
That's what, yeah, so you do the reciprocal, and what else?
You multiply by a negative?
Yes, you make it opposite sign, or switch its sign, and you flip it. So one of my students would say switch it and flip it, right? You switch it, meaning you switch the sign, and then flip it. So in this case, if this were perpendicular, this problem would only change right here. Take a look where I'm changing it. Instead of using -1/2 x plus b, I'm going to use 2x plus b, because 2 is the negative reciprocal of -1/2. So this is the slope of the line we had. If we want a line that's perpendicular, we can now change this to a 2. And it's the same throughout now. The problem is going to give me a different answer. B is going to turn out to be 1. Okay, B is going to turn out to be 1, which is right here. A slope of 2 over 1 means the line's going to look like that. And lo and behold, a y-intercept of 1 is right there. A positive slope of 2. Those lines look pretty perpendicular, don't they? Okay, again, this is not on a grid, so I'm doing this by estimation on the board. You will definitely have a set of axes and grid lines on your test to graph on. So you should be precise, and you should use a straight edge. Whether that be your ID card, that's fine with me. Just have something with you to use as a straight edge. I'm happy to give you rulers. There's rulers in the room if you want to get them before the test. That's fine. But just bring something you can write with a straight edge for. Okay? Em.
If the slope is a negative 1/2 and the negative reciprocal, how is this possible?
It's the negative reciprocal. The slope of perpendicular lines are negative reciprocals. Switch it, like switch the sign, and then flip it. Okay? Questions on 3.3, 3.4. We had one other thing in that section that I haven't really gone over, but no one's asked it. There were a few questions in your problem set and your homeworks where it was like, find the value of k such that this point is on the curve or something like that. Do you remember those problems? Want to do one of those real quick? Is that reasonable? Were they really easy? I don't know. I don't want to waste your time if it's too easy. What time is this period over at? 15 minutes still? Awesome. Yeah? No? Somebody check here real quick.
Oh, it ends at
It's
37.
science, it's not 13.
Ends at 37.
Oh, it is right here. I'm sorry. 37. All right, so, okay. Nice. 13, 14 minutes. Perfect. So let's do a quick example of that. So let's say we have the following line. L is given by the equation 2x plus ky equals 17. And the question says, determine the value of k such that the line passes through the point 1, 4. Determine the value of k so that this line passes through the point 1, 4. If a line passes through a point, what can you do at that point?
You plug it in for X and Y.
Exactly. All you have to do is plug it in for x and y, and what do you have to solve for?
Okay.
K. Good? I don't have to do this, I don't think, algebraically. You can do it on your own. What if I said this? Determine the point k, or determine the constant k, not point, I shouldn't say, the constant k, again still 2x plus ky equals 17. Determine the constant k such that, or so the slope is 1/3. So that the slope is 1/3. Find out what k is. So the slope is 1/3. How'd you do this? It's in standard form, right? In standard form.
It's 1/3 equals 2 over k.
Yeah, so in standard form we use negative a over b. So negative 2 over k would be the slope of this, right? Well, if the slope I'm telling you is 1/3, and then I'm also telling you that it's negative 2 over k, those have to be equal to each other by the transitive property. If m equals this, but m also equals this based on our problem, we know that those two things have to be equal to each other. So you end up with a proportion, really, right? Inherently, link these two together. You get really, the slope is 1/3. The slope here is negative 2 over k, so 1/3 equals negative 2 over k. What must k be? By inspection, just look at it. Don't solve it, just look at it. Negative 6. Negative 2 over negative 6 is 1/3. Okay, k should be negative 6. There's no reason you need to multiply, cross multiply and divide. I mean, that should be easy for you guys. Okay, look at that and just see that there should be a negative 6, because negative 2 over negative 6 reduces to 1/3. I want to pause for an instant and address something. Take your calculators, please. Something that I wanted to go over in class, and I don't know how I forgot to, or if we maybe ran out of time. I'm not sure which one it was, but I was annoyed with myself that I hadn't done this, so please take out your calculators. Hey, recall real quick that in section 3.5, we studied elimination, substitution, and then eventually led on to the matrix method, the idea of entering into a matrix. So imagine that I didn't want to use any of those three methods. If you remember, the solution to two linear functions is where they intersect. So if there's one solution, they intersect once. If there's infinite solutions, the lines are on top of each other. If there's no solution to a system, the lines are parallel. Remember those three statements we had? So let's say that I want to find the intersection of the following. Y equals 2x plus 4 and 3x plus 8y equals 9. I want to find the intersection of these two, but I want you to do it not with substitution, which is obviously very easy to use, right? But I want you to do it graphically. Now, you might say, okay, I can graph it and find the intersection on a graph, but your graph needs to be very precise for that to work well. And you probably won't be able to get the exact answer. So we're going to go to our calculator and go through this. So, together, let's do this. For the first equation, y equals 2x plus 4. Just type that in y1. 2. Here's the x. Remember, the x is above the apps button. Above the button that says apps. 2x plus 4. What about y2? It's the To solve for y, remember I have to have y equals for y2. So what would y become in the second equation? Remember, the equation right now says 3x plus 8y equals 9. That's our second line. Solve that for y.
And y equals 9 minus 3x divided by 8.
All over 8, right? Good. The quantity 9 minus 3x all over 8. Now, you can leave it like that. You don't need to put this in slope-intercept. As long as it's equal to y, that's all that matters. And I would do exactly what James just said. I would do parentheses in my numerator. 9 minus 3x all divided by 8. See the way I do that? I would type it in just like that. There's no need to find the slope and the intercept explicitly. Right? The intercept would be 9/8. The slope would be -3/8. Who cares? It doesn't really matter in this case. It doesn't matter. All that matters is where these two lines intersect. What should you press next? What do you think you should press next? Enter, or after that to see what they look like? Yeah, go ahead and graph it. There's our first one. There's our second one. Where do you think they intersect? Just by looking. Don't even trace. Don't even use any functions if you know how to already. But where would you guesstimate they look like they're intersecting? Just give me an idea. What does it look like based on your graph? Anyone? Give me to the nearest integers. What would you say they are? Around.
-2,
Yeah, -2, 1, or -1, 1. In there somewhere. Absolutely. Okay, but you don't know what it is. Agreed? You can't see by inspection. So press second. Press second.
Mine isn't even showing up.
Hit zoom 6, James. Hit zoom and then hit the number 6. Tell me if it works now. Did it work now? Let me see. Quick. Because your equal signs are not highlighted. Look at your equal signs. Go on to them and hit enter. And whatever you're on, to the left of the Y, there's like a symbol on your James. I don't know what setting you changed, but it might graph in a funky way.
It says I can only highlight one.
Alright, so look at the left here. Take a look at mine. Look at the word. See on the left here, I have these lines on them each? These should all be lines. If I keep hitting enter on these, it's going to change them. You have something like, I think you have this, whatever that is right now. It should all be on linear, on linear functions like that. And you should be able to highlight both. So just maybe follow along for a second and I'll look at your calculator to see what it could. If anybody's played game before on it or changed it.
It's my brother's.
Yeah, so you might have changed some settings. I can set it back in. For now though, okay, this is what we have again. We want to figure out what the intersection is of this right here. So I press second, then hit this calculate button, which is the trace button really, to bring up the calculate command. But which one do you think I'm going to choose? What am I trying to find? So what number, which one am I going to choose here? Number 5. Look at number 5. Where's number 5 sit? Right? Intersect. We're trying to find the intersection. So hit enter. Now, when there are two lines intersecting, there's only one intersection, right? So it doesn't matter what your first curve, second curve guesses are. It's only if there was, imagine there was a problem and I had a line. And I asked the calculator to find the intersection. How is it going to know which intersection to choose, right? So if there's more than one intersection, you need to specify and get close to that intersection. But now you don't, because there's only one intersection. So hit enter, hit enter, hit enter. Just hit enter 3 times. Hit enter 3 times. Okay, again, if there was a parabola and a line with 2 intersections, you'd have to get close to the intersection you wanted and show that. But for now, just hit enter. Okay, you get the intersection of -1.2, 1.6. Okay, that would be the exact solution, or if I'm rounding rather, I'd say that would be the approximate solution. But that, what they're trying to give you there is the exact intersection. If you solve this by substitution method, which you can easily do, plugging 2x plus 4 in for y here in the second equation, you would end up getting an answer for x that is -1.210526, but it would probably be the fractional form for that. Okay? So you should be able to use your calculator to at least come up with an intersection. If I ask you to come up with the intersection using your calculator to the nearest 1,000, I want you to practice this technique. Let's go through it one more time together. So So if I change the second, well, the first equation, let's make the first equation now, let's make it 3x plus 1. And let's make the second one 9 minus 2x all over 8. Just to change things up a little bit. Okay, so I'm going to make my equation now that I have on the board. If you want to take a minute to write that into your calculator, type it in. 3x plus 1 is y1, and then y2 is the quantity 9 minus 2x all over 8. Hit graph so you get an idea of what they look like. Now, if those lines didn't intersect on your graph, you might have to zoom out a little bit, but they both happen to. So we don't have to hit the zoom feature or zoom out, so let's just go to second, calculate. We want to find the intersection. And again, if you had more than one intersection, you'd have to move left and right with your arrow key. See how this moves? Look how I'm moving? And you want to get closer to the intersection. But because there's only one intersection, just hit enter anywhere. Doesn't matter. Hit it 3 times. Okay, the intersection is 0.038, comma, 1.12. So the nearest thousandth would be 0.038, comma, or it's the nearest, let's see, 10, 100, yeah, it would be 1.115 then for the y value. Okay, but just practice doing this, practice so you're good at, finding the intersection of 2 different equations. What's the last thing for this test we have to go over soon? The next minute or two, just to quickly reiterate, because we just did this recently. After we did elimination, substitution, and matrix, we did those with word problems, remember? Okay, so be able to use elimination method, substitution method, all these methods with word problems as well. So, just to show you real quick, if you want to remember, I had you guys do an example of substitution method where you had to solve for x in terms of k, one of those in your notes. You should definitely be able to do that. And elimination you should be able to do also. So elimination, if you had like this. Okay, being able to solve this with elimination, I'd multiply the second equation either by 4 and then add it to cancel out the y, or multiply it all by -2 and then add it to this to cancel out the x. So you could solve this by elimination. You could solve this by substitution by moving the y over. You get x equals something, plug it in for x. We also, though, had this. And this was the one that was a little bit trickier with substitution. We also had, I hate this stuff. We also had 2k plus x equals 4y, and then x minus, I don't know, let's say 3y equals 4. In this problem, I'd say solve for x in terms of k. Well, in a problem like this, you can do that. You can solve for x down here, or solve for y, either one. You can take this expression, plug it up here, that will give you y in terms of k. Or you could have this equal to x, solve for x here, set them equal to each other. Just practice that from your notes. Okay? As far as the pay base, you have the full period of the test. That's pretty much it. If you have a quick question on something after school, come by, I'll be around. So just come by after school, you have any questions and stuff? Okay? Yeah, bring it up. Let's take a look at it right now.
Did you ever have chicken?
I did not. I've only been here for 4 years.
Yeah, that's when
He was probably a senior the first year I was here. Here you go.
So,
Just try it out yourself.